afternoon to all the students. I am Dr. Hima Bindu from the Department of Mechanical Engineering, and I'll be dealing the subject robotics in Institute of Aeronautical Engineering. And my today's topic is task space dynamic control. In the previous sessions, we have discussed about the various design principles, or we have gone through the generalized equations, or we have come across the dynamic controls used in the robot, which are one of the advanced topics used in the robots. In the same way, this task space dynamic control system is also one of the advanced technologies which we will be using in the robotics. So about that we'll be discussing in today's session. So what do we mean by the task-based dynamic control system? First, we need to know that this particular task-based dynamic control system generally is used to involve the control of the robot motion and behavior. Right? This particular task-based dynamic control system is used to involve the controlling of the robot motion and behavior directly in the task space, where the space with the robot's end effector operates, right? With the help of which the robot's end effector operates. This particular constraints with joint space control, where the robot joints are controlled to achieve a desired position or the trajectory. Now, in this particular task space, we have two types, that is joint space versus the task space. So what is the difference between the task space and what is the difference between the joint space, which we will be seeing? So here in the task space, it refers to the space in which the robot performs its task, typically defining the position and orientation. Right? Task space define the position and orientation of the robots and effector arm or the manipulator. Whereas in the joint, it is used to describe the joint angles or displacements. Right? In the task space, we will be identifying the position or orientation of the robot's arm or the end effector gripper. Whereas in the joint space, we will be coming across the robot joint angles or the displacement. Now, coming to the operational space control, this particular type of the framework is applied directly in the task space. Right? This is a framework which has been applied directly to this task space, where we can achieve the primary goals such as regulating the position or orientation and the force of the robot's end effector in the operational space. And this particular operational space is often utilized with the help of the Jacobian matrix. Right? The operational space is generally utilized with the help of the Jacobian matrix related to the joint velocities at the end effector velocity. Whereas the dynamic equation is used to express the task space using the Jacobian and its derivatives. Here we are just using Jacobian matrix, whereas in the dynamic we are using the Jacobian and its particular derivative. Where it is used to describe the force and the torque. Right? Where it is used to describe the force and the torque, which are translated into motion and vice versa in the task space. Next, moving on to the control strategies. Now, this particular control strategy is used to impedance control, to admittance control, or to find out the resolved acceleration control. So what we have already discussed in the earlier session about the impedance control. So what do we mean by this particular term impedance control? This impedance control is used to give us the relation between force and position. The impedance control is used to give the relation between the force and the position, which is used to achieve a desired dynamic behavior with respect to the interactions with the environment. And this admittance control is used to regulate the robot motion in response to the external forces typically used in compliance control scenarios. And the resolved acceleration control is used to control the end effector acceleration. Right? The resolved acceleration control is aimed to control the end effector acceleration in the task space, ensuring that the desired trajectory is being followed. So these are the three control strategies which will be followed in this task space dynamic control, that is the impedance control, admittance control, and the resolved acceleration Next, coming to simulation and modelation. How will we do the simulation and modeling for the already designed robot? So what are the techniques being used for simulation, that we will be seeing. So here this is one of the very important aspect of simulation and modeling in the robots. That is, simulating and modeling is a critical component in developing and testing of the robot system. In order to do a development and testing of the robot system, simulation and modeling plays a very important role. So they provide a virtual environment to design, analyze and optimize the robotic behavior before deploying in the real world. So here we are coming across the prototyping and designing and cost reduction. These are the main important purposes of simulating and modeling. What do we mean by prototyping and design? This initially, before we come across manufacturing any robot, we need to prototype that particular design, and we need to do the design modeling in some particular required software. Before building any physical prototype, robots are designed and tested in virtual environment to explore different configuration, materials and mechanisms, which will help in reducing the cost. This cost reduction is very important. That is, robot system developers can reduce the cost associated with physical prototyping, testing and potential failure. Safety testing and performance optimization are also very important. So safety testing means simulation allows testing in hazardous or extreme conditions that would dangerous or explicit to duplicate in the real world. Safety and performance are also very important. So we have different models where we come across this particular design, that is kinematic model and the dynamic model. First we need to model the kinematic and the dynamic model and do the design testing. That is, generally kinematic model is used to which involves the equation like joint angles, velocities and position in the safe space, whereas the dynamic models involves the effect of gravity, friction and inertia, right, where we are implementing the gravity, friction and inertia, where how the robot will move under specific conditions is very important. Right, and the sensor model and environmental model also very important. Here the sensor model means we need to test the sensor based algorithm. Before inserting the sensor model, we need to test that particular algorithm before we are inserting it into the robot. That is, we need to simulate the data of the sensors which can generate the real world, including noise and inaccuracy, and then only we need to insert that in the robot. And when we come across the environmental condition, we need to take care that it includes it can identify the obstacles, terrains and other dynamic elements. Right? Simulation. What are the simulation tools which we can use? That is Bullet or Open Dynamic Engine or 5SX. Right? 5SX are the physical engines which are being used for the physical engines. The simulation tools which we generally use are Bullet or Open Dynamic Engine and 5X, which are used to identify the physical engines, including the gravity or physical interaction or the collision detection, or it may come under the rigid body dynamics, right? So, and other than that, we have gazebo. Right, gazebo is one of the important technique which is coming up now, which is widely used in conjunction with the robot operation system. That is, we call it as ROS, for simulating complex robot in dynamic environment. Or VREP. VREP is also very important, where it plays a very versatile role and the ability to handle multiple robots and the sensors. Of WebOts. WebOts is also one of the tool which we can use for the various robot systems and the environment, or the CAD software. As we all know, CAD is one of the easy software like SolidWorks or in AutoCAD or in Blender. Also, we can do this particular type of the simulation designs. And other than that, we also have a robot simulation. These are some of the robot simulation platforms which we can use for the simulation purpose. That is Gazebo, VREP, WebOts and CAD software. So depending upon the usage, depending upon the type of the software we have learned, we will be using either of that. But among all these, I can tell that the CAD software is one of the easy software in which we can do simulation and designing for any particular robot design, right? And the applications of the simulation are generally used for path planning and navigation, manipulation and grasping, autonomous vehicle or human robot interaction. Like, what do we mean by path planning and navigation? Generally, this is used for testing the algorithms that guide the robots through different environments, ensuring that they avoid the obstacles and reach the goal very easily and effectively. That is the known as path planning. Whereas manipulation and grasping means when we come across the robot arms or the gripper, we need to optimize the object handling and interactions task critically in industries and the service robots. So that is, these are few of the applications which we come across in simulation. That is path planning and navigation, manipulation, grasping. All the remaining two we already know. That is autonomous vehicle and humanoid robot equation. In all the different tasks, these are one of the common applications, right? Limitations. What are the limitations? That is realism versus computation or model accuracy and a transfer to the real world. These are few of the limitations which we need to strike. That is when we need to have a balance between the realism of the simulation and the computation efficiency. This acts as one of the challenge which we need to come across to generate the resource intensivity, or when we come across the simulation which is only good as the models used. So this particular type of the simulation inaccuracy in model can lead to results that doesn't translate well to the real world application. Or when we come across the real world challenges, these are the challenges known as the sim to real gap challenges. That is, this is one of the major hurdle which come across the task system, or which we come across the simulation modeling. So this is one of the important thing which we need to consider and take care of. So these are the differences which we have gone through for this one. So in today's class, we have discussed about the various limitations of the simulations and what are the different applications. We have gone through the various robot simulation platforms like Gazebo, VREP, WebBots or CAD software, in which I've said CAD is software is one of the easiest and more applicable type of the software for simulation and designing. And since we have seen about the sensor models, environment models, or we have come across the simulation tools and softwares, we have seen different types of the models of the safety testing, performance optimization. We have known about the general simulation modeling. What is the exact purpose of simulation modeling, or the control strategies we have seen, and operations based tasks, and what exactly is the task space dynamics, and what is the difference between this task space and the joint space. All that we have discussed in today's class, right? Hope you have understood today's session. Thank you. Signing off for today, Dr. J. Hima Bindu.
Like, share and subscribe. Hit the bell icon for more updates.